hope that you are all safe and you are all doing good. So today, this is the schedule for the workshop. So in this whole workshop, we will be discussing these three topics. So basically, uh, on the first, our first topic will be that how can we make a personal oscilloscope, and after the completion of this topic, we will discuss that how can we make a pocket function generator. So see, look, if any terminologies like this oscilloscope or function generator seems new to you, then don't worry, because we have designed this workshop in such a way that the student who does not have any idea of all this topic can also build these two devices. And if the time will permit, then we will explore about this topic. So basically, right now we will be covering these two topics, and later on, when time will be there, then we will discuss upon this topic. Okay. So let's now jump to our first topic. So this is basically the outline for the first topic, in which we will learn that how can we make a personal oscilloscope. So see, before making anything, suppose here we are discussing about making an oscilloscope, then the first question that comes in the mind is that why should we make it? Okay. So the reason being that if you know the reason that why we need any particular device, then only we will focus on building this. Okay, so that's why I think that it will be very appropriate to discuss at first preference that why should we have a personal oscilloscope. Okay, we do have oscilloscope in our college for labs, and we have one separate oscilloscope for electronic stuff as well. But why I am focusing on personal oscilloscope? Why I am saying that every student should have their own oscilloscope? Okay, so this will be covered in day one, means today, and after that, after discussing this why, we will be focusing upon that how can we build a portable and handy scope. Okay, so first we will discuss that why should you build a oscilloscope, and after that we will see. Now once we have understand that how means why should we build it, then we will look on the opportunities that how can we build it. Okay, and after this, on the day to itself, there will be a hands-on session upon this. So by the completion of this first topic, I can assure you that you will be able to make your own oscilloscope. And for making this oscilloscope, you need not to be from a particular background. Means what I mean to say is that if you are from mechanical department or any other department, then also you can build this oscilloscope. It is not mandatory that a pure electrical engineering guy can build this scope. Okay, so let's move to content of the day one. So as I have promised you that this workshop will be such a manner that everybody can understand this. So I have that's why I want you to start this from your school days. Okay, so let's go back to the school days. In your school days, you might have done a lot of experiment on electricity and electromagnetism in your 10th and 12th standard. So in all those experiments, if you will recall, if you just give a thought, take a moment and give a thought that suppose in the Ohm's law experiment where you try to prove that the voltage is equals to current into resistance. Okay, so for the verification of this law, when you perform any experiment, when you do the experiment, then you see this is the circuit will be like this, but you will see these two guys, this voltmeter and this ammeter. This is used to measure the current, and this will be used to measure the voltage. Similarly, if we will take another experiment, that is, for example, potentiometer experiment, here also you see a device which is used to measure the current. See, what I want to say is that the name of these experiments are not important for our session, but what I want to show is that no matter what kind of electrical experiment or electrical work you are doing, you will need the measuring instruments. You will need some instrument to measure the electrical parameters. And why do you need an electrical instrument? Why can't you do any experiment or anything without these instruments? Because nobody can see the electricity. Okay, we can't see the electricity. So if you are doing something that is related to electricity, you will have to use those measuring instruments so that you can understand what is happening in the circuit. Okay, so here, to do any work related to the electricity, we need to have the measuring instruments. Why we need to have a measuring instruments? Because they are the eyes and ears of an experimenter. Okay, from this only you can know about the circuit. So once we have understood that why we need an measuring instrument, let us go to our next slide. Okay, so one more thing, these things like this voltmeter, this ammeter, and this multimeter, you might have seen many times in your lab, even in your school times as well. Okay, so yeah, this is the next slide. So in this slide we will be discussing that. See, now the instruments that we have normally in your labs or in your schools, okay, like voltmeter, ammeter, and multimeter. Okay, all these instruments along with some wattmeters. So we do have all these kind of instruments. Okay, but why we need a particularly an oscilloscope? Because the instrument that we normally used, like voltmeter, ammeter, or multimeter, they can measure only the DC or AC value of a signal. What does it mean? It means that suppose you are using a multimeter to measure the voltage of some point in your circuit. Okay, then the multimeter will show you just the value, like it's, let's say it's a 5 volt, 10 volt, or 12 volt, but it cannot show you that how that voltage looks like. Okay, and it cannot show that how that voltage is changing with respect to time. So that is the thing which we are interested in. Okay, now see, now what we should understand that, see, one should ask a question that why are we interested in viewing the waveform? Means how, what is the necessity to look upon that voltage, that how does it look? See, the reason is that most of the voltages in the electrical projects, like let's say some projects on the robotics, or some projects on embedded system, some projects on Arduino, you all are doing this kind of projects. Okay, so in all these projects we use a lot of sensor, bunch of sensors we use in all these projects. Let's say you use an object detector, infrared sensor, PIR sensor, and all these sensor. Let's take an example of object detector. Okay, so those who don't know what is object detector, let me just tell that briefly, that object detector is just a sensor board which can detect the object. Means suppose the object detector is placed somewhere and anything come in front of that object detector machine, then what will happen? If anything will come in front of that, it is going to give you the signal. So if you look closely, then what is happening? If anything is coming, the voltage is changing. So in all these scenarios where we are using sensors, the voltage is not constant with respect to time. They are changing. And it is very important to measure and to see that how these voltages are changing. Okay. And the second in the second area where this is important is the Arduino and a lot of microcontrollers. Nowadays, it is very difficult to imagine any electrical project or any robotics project without the integrated circuits or microcontrollers or microprocessor, or using without any chip. So basically you are using this, we are using these microcontrollers and a lot of DSP chips, ICs. So all these things have bunch of analog data and digital data which are continuously changing with respect to time. Okay, so it means that all this changing data. Okay, so when you have this kind of changing data, then all this data need to be observed during designing, debugging and development stage, because while designing it is very important to see all the waveforms, that how the circuit is behaving, so that we can send this, we can actually look upon the circuit that what is happening. Okay, and the second reason is that, see, normally when we buy a component or do any circuit designing, we assume certain idealities. We assume that something, many things are ideal, but in the real world they are not ideal. In the behavior, in the real hardware is going to very totally different from your simulation work or from what calculations you have done. So it is very important for a good circuit designer to use all this instrument and to measure exactly what is happening with your board. Okay, so when we look all this necessity, then the name of the oscilloscopes comes into picture, because oscilloscope is the device which can give you the ability to visualize all this data, like this sensor data, Arduino signal data, and this digital and analog data. All these things you can see in an oscilloscope. So here in this slide, basically what we have discussed is that why we need an oscilloscope in this era. This era means initially in the 90s, the projects that we were doing were not that much integrated. There were not a bunch of analog sensors or digital devices, but now no matter what project you are going to do, you have a lot of data which is changing with respect to time, and you need to see those data for a better designer. So with this, let's move to the oscilloscope. Okay, so in the earlier slides we have discussed that why do we need an oscilloscope. Okay, now in this slide we will see that what is an oscilloscope and how does it look like and what are the applications of this oscilloscope. Okay, fine. So as I have shown you the definition, that oscilloscope is a device which can display the shape of the voltage signal. Means basically when you use an oscilloscope, this is the simplest definition of the oscilloscope, that it shows the shape of the voltage signal. Now what do I mean by the shape of voltage signal is that, just for an example, I have kept some signals here for you. So let's say it can show you the sine wave like this. This is the sine wave. It is the square wave. It is the triangular wave. It is the sawtooth wave. So if any of the signal is present in your circuit, the oscilloscope is able to show you these waveforms. Okay, and this is how the oscilloscope looks like. So in the oscilloscope, mainly these are the main parts of the oscilloscope: this display, vertical control, horizontal control, and the trigger control. Okay, so don't be panic. I will be discussing all few important out of this. So basically, this is the first thing, first part of the oscilloscope, and this is the most important part of an oscilloscope. So here you can see that oscilloscope is the device which shows the voltage with respect to time. So here in the y-axis, this axis is for the voltage. So here you can see the amplitude of the voltage, and this is scale. This x in the x-axis you have the time. So let's say, suppose, okay, this is the display. Now this is the input terminal of the oscilloscope. This is the point from where the oscilloscope gets the data. And basically, suppose let's say in the you all might have used the multimeter. In the multimeter you have two terminals, and that two terminal you connect to the circuit where you want to measure the voltage. So for the oscilloscope also this is quite similar. What I mean that, In the multimeter, you have the red and black probe. Here you have these two probes. This is the ground clip and this is the probe. So basically you connect the negative terminal to this node and you connect the positive terminal to this node. And the data, that voltage information comes via this probe to the oscilloscope. And oscilloscope process this data and display that data. Yeah, oscilloscope process that data and display that what kind of voltage is that. Okay, so this is how the oscilloscope looks like. Now see, if you have any question, you can ask those questions in the chat box, because after this I'm planning to show you the oscilloscope that we are going to make. We have a working oscilloscope, so after some time we will be discussing on that. Okay, yes. So till now, I think that everybody has understand whatever has been discussed. So what we have discussed, just we will recap that. So basically, in this first slide, we discussed that why do we need a measuring instrument? Okay, and after knowing the reason that why do we need the measuring instrument, in this slide we focus that why we need an oscilloscope. Means if we have a lot of measuring instrument, then on top of that, why do we need a oscilloscope? And in this slide, we have discussed just in brief, because we will be discussing about this oscilloscope in the next session as well. That's why, not to make you panic, I have just make it very brief. Okay, so this is the very short description of an oscilloscope. Now, I would try to just show you that how the oscilloscope works. So don't mind, because it is not a very detailed circuit. I don't want to make the circuit very detailed, because for few students it might be a very boring kind of thing. So that's why I have made it very brief. So here, yeah, here you can see that we have a circuit for half wave rectifier. And in this half wave rectifier, let me just give a brief introduction of the circuit. So basically we have a sinusoidal source. Okay, this is the sinusoidal voltage source, and we have connected a diode across this, and we have connected a resistance. This is just to show you the working of an oscilloscope, so that when we will build the oscilloscope, then our concepts should be very clear. So you all know that when you give a sinusoidal input at the input of an half wave rectifier, then the output looks something like this. Okay, so now this is our circuit, and this circuit is connected. See, this is the oscilloscope. Okay, so basically this is the circuit, and we are giving this voltage, we are measuring this voltage from the oscilloscope. So when we connect these wires, so yeah, in the real world, suppose this is your circuit board, and you have connect your circuit board to the oscilloscope using the probe. How does the probe look like? You like this. Okay, so basically here we are connecting the circuit. Okay, this we are connecting to negative terminal, and this we are connecting to positive terminal. So this probe we are connecting to the oscilloscope. Okay, so yes, so this is connected via probe. Yes, and in the oscilloscope, basically there are three sections. Okay, the first section receives the data. Okay, the first section receives the input voltage, and after that there is a processor, and at the last stage there is a display. So how does it reads the voltage? I have said that this block basically reads the voltage. So actually this the first input stage is having an sampling circuit. What a sampling circuit does, it basically reads the input voltage. Suppose you have connected this wire, suppose you have connected this wire over here, so the voltage is changing. Okay, it's like a half wave sine wave. So it will sample that voltage in the different intervals at very fast rate and convert that voltage into digital data, and that data will go to the processor. Okay, now what the processor will do, processor will perform certain important algorithms on that signal, and it will basically try to figure out that how, what kind of signal is that. Okay, and after performing all the calculations and all the signal processing, it gives the data to the display. Okay, and the signal is displayed to the user. Okay, so basically you can see that the output voltage will be appear on the display like this. You can see this half wave sine wave. Okay, so this is a block diagram kind of thing for an oscilloscope. Now, as we have promised, as we, the electronics club, has promised you that we will teach you to build an oscilloscope. Now, see, the oscilloscope that we normally have are very expensive. And what is the most expensive part in the oscilloscope is this processor. So the processor takes a huge percentage in the cost of the oscilloscope. Okay. Now, suppose, let me write down the challenges that we have with the current oscilloscope. So first challenge is they are too expensive. Okay, and the second thing is that in your labs also you might have seen that the oscilloscope are very big and bulky. Okay, so let's say you are doing any project work in the electronics club or in any club, and after that you are going to a different location, let's say in hall 13 or somewhere, to do that experiment. Then this oscilloscope, because of their size, they are not suitable to take from one place to another place, so it's kind of annoying thing. So we will try to sort out these two challenges, this expensive one and this big and bulky. So we will learn to make an oscilloscope that will be pretty affordable, and this will be very compact and small in size. Okay, so how we will do this, let us see. So let's focus upon the main components of this oscilloscope, and we will see that how can we replace those components with the other ones which are really cheap and available to us. So as I have told you that the most expensive part of any oscilloscope is the processor. Now if we can find an alternative for this processor, what I mean that if we can use any processor that we are that we are already having, instead of getting this dedicated processor, then we can reduce the cost actually. Now what is the best option for that? See, we all use the laptop and desktop. Okay, So our laptop do have a processor. So for making our oscilloscope, we will use the processor of the laptop. So instead of a dedicated processor, we will use the processor of the laptop. Okay. Yes. So in this way, we have cut down pretty much amount of the cost by replacing the by using our laptop processor instead of buying a new one. Okay. Now let's this you all can answer, right? This is the display. So in our laptop we do have a display. So if we use our if we use the display of our laptop, we don't need to buy a new one. So here we can save cost. So we will use the monitor of our laptop as a display, and we will use the processor of our laptop to processing that data. Now the last part is that how will you get the sampling circuit? Okay. So as I have already told you, what is the function of the sampling circuit? Sampling circuit it's just a simple circuit. What it will do, it will take the input data, sample that data, and convert that data into digital form. Okay. So basically, it will convert the data to digital form. Okay. Now, now we have to look for a sensor for a complete sampling circuit which can do this job. So just give a thought that in your laptop or in your mobile phone or in your tablet, can you think of any sensor that you use all the times, most of the times? Just give it a thought. I will give you the answer. So I think you will think about something. So if you give it a focus, then you will find that in our laptop, mobiles, tablet, we do have a sound circuit which converts our sound wave into electrical domain. Okay, first it convert our sound into electrical domain, basically in the analog input, analog output, and after that the sound card which is there in our laptop that converts that input sound data into digital form. So yes, we will use our sound card. Okay, we will use the sound system of our laptop slash desktop to make sampling circuit. So I think till now whatever we have discussed is clear to you. So let me just repeat it once more. So basically this is the ordinary oscilloscope that we have. Okay. So here it has a dedicated sampling circuit, dedicated processor, and dedicated display. Now, as we want to build all these things in a low cost, so that's why we are using processor of our laptop, monitor of our laptop, and the sound system of our laptop for making these respective stages. Okay. Now, tomorrow we will discuss that how we will build it. But today, I would like to uh, do a hands-on session kind of thing on this oscilloscope, because we have already learned that how are we going to make this oscilloscope. So I will just give you the glimpse of the hands-on session that we will be doing tomorrow, so that you all can be familiar with this. And those students who have downloaded the software that we have mentioned on the Slack, please open your software. I will also be opening my software in my laptop. Till then, just wait for a moment. Yeah, it will take a few minutes to connect my laptop to this screen. Till then, just enjoy a song. Okay, this is just for the time being. I will be doing the work in the background. Till then. Yeah, so I have connected my screen to my laptop, and now I will be showing you the oscilloscope. Yeah, so this is the software interface of our oscilloscope. Uh, so today I will be just giving you a few hints that how we can use this software in further. We will discuss about how to use this oscilloscope on tomorrow. So if you don't understand anything, just don't worry. Just see that how means what outputs we will be getting at the end of this workshop. Okay. So basically, this is the software interface of our oscilloscope, and here we have see this oscilloscope, and will do and give it a sine wave. So basically, I will generate a sine wave inside my laptop, and that sine wave will be displayed through the oscilloscope in the screen. So see in the channel one, I'm generating a sine wave. So yeah, I forget to mention that all the students who are having the software can also open the software along with me. So I will just close it and I will again reopen it so that you can follow the steps. So basically you have to double click on the application, and here this license program, go for continue. Okay, so this is the software interface. Now first of all, you just go to the setting and put it on, yeah, stereo mix, this loop back speaker HP. In your system there might be many other options as well, but go for this one, loop back speaker HP. Okay, so just click it. Now these are the settings that we need to do. Now I'm going to generate the signal. Okay, so yeah, here after doing this setting, just go to the signal generator and just turn this on. So the moment you will turn on this, you will hear a sound from your speaker. So you can increase the volume of your laptop so that you can hear it if you want to hear it. So basically what this is doing, this is generating a sine wave of 440 hertz on the left channel and right channel. So in your laptop, the sound in your sound system, you basically have two speakers, the left one and the right one. So these are represented here as channel 1 and channel 2. Okay, so now your laptop is generating a sine wave. Now we will measure the voltages across that speaker of your laptop in the oscilloscope. Now just click here to open the oscilloscope. Yes. So as you can see here, the waveform is going out of the window. So just go for the amplitude, go in this section. This is basically the amplitude section where we adjust the y-axis, the scale of the y-axis. So just move it little bit this side. Okay, towards 1. You move it towards 1. So when this waveform will be within your screen, then you will be able to see the sine wave that is going in your speaker. So basically now what we are doing, that we are giving a voltage on our speakers, and our laptop is generating a sine wave across the speakers, and that voltage is coming to our oscilloscope. Okay. We are measuring the voltage of our speakers because we are not present physically, means we do not have a lab. So when we will meet in our campus, then I will show you that how can you measure in a similar manner. You will be able to see the voltage waveforms of your circuit instead of the speaker. This is the voltage of the speaker right now. You can also see the voltage of your circuit in a similar manner. So let me just separate these two waveforms. Actually here left channel and right channel, we have two channels. So to separate this, just click here, you see a line, just drag it to upward. Okay. So basically we are having two sine waves, and you can zoom it on the x-axis, means horizontally. If you want to zoom it, you can do like this. So see, the nice sine wave is present in our screen. Okay, so this is just a demonstration that how can you generate a sine wave and how can you measure that sine wave from your oscilloscope. Now suppose if you want to know that what is the frequency of this oscilloscope, then we do have a feature to measure the frequency and the amplitude. So basically if you click here, see the frequency in the channel 1 is green. So frequency in the channel 1 is 440 hertz and frequency in the channel 2 is also 440 hertz. Now what we will do, if you want to do this, then you can just go to signal generator and you can change the frequency of the signals. Suppose I put here 1010 hertz. Okay. So, and here, okay, so see, the frequency of the second signal has changed. It is not stable because we need to take this trigger point. This is the trigger point. So wherever you want to stop the waveform, you can go on. So see, this is the 440 hertz waveform, this red one is, and the green one, the frequency has gone up to 1.01 means 1010 hertz. So like this, we can generate a lot of signal and we can measure those signals here. Now, just for the relaxation purpose, I will do one thing. You all might have heard about the X-square plot in the oscilloscope. So what is the X-square plot? Basically, that in the x-axis it will plot the waveform that is present on channel 1, and on the y-axis it will plot the waveform which is present on channel 2. Okay, this is also known as Lissajous figure. I just want to show you some figures. So let's go here. This is just for a demonstration. You all also can do. If you are not able to, if you are not getting that why is it happening, just don't worry, we will explain it to you tomorrow. So suppose here you set 450 hertz. See, now you can see something that is really exciting. See, this is known as the Lissajous figure, and it's keep on changing from time to time. Okay, if we remove the grid, see, you can see this plot. Yeah. So just I will tell you all these things. If you are not getting, just don't worry. We will discuss it tomorrow. And one more point I want to say that this is known as the oscilloscope music. Okay. Just let me turn off this software. Yeah. So the moving diagrams and moving waveforms that you were seeing is also is actually known as the oscilloscope music. Okay. So I think there are some questions from chat menu. Let me answer few of them. So the question like, what does this oscilloscope music imply? Is the voltage across what? Okay, yeah. So Parth has asked this question. The question is that I will share the screen so you all can see the question. Yeah. So Parth has asked a question that what does this oscilloscope music imply, and is it the voltage across what? So actually oscilloscope music. So we will go to oscilloscope music a bit later. So before this, I would like to tell you that what is happening on the screen. So we do have two channels, means we have two input voltages. Okay. We have two input voltages which are changing from time to time. So just for example, suppose if you have, so basically in the x-axis you have channel 1 and in the y-axis you have channel 2 in the x-y plot. Okay, so x-axis is channel 1 and y-axis is channel 2. So uh, if you just see, I'm just giving you the answer. Just wait a moment. Yeah. So in that particular screen, that XY plot, that is known as XY plot. In the x-axis we have channel 1, means we are having one voltage on channel 1 and we are having another voltage on channel 2. Now as I have told you that in the laptop, our laptop is having two speakers, so it has two speakers. This is speaker 1, which is, let's say, left speaker, and it corresponds to channel 1, and we have the right speaker which corresponds to channel 2. This is speaker number 2, the right speaker. So now what we are doing, as you might have seen that on channel 1 I am giving a sine wave of 440 hertz, and the frequency is changing from 440 hertz to I think 600 hertz. Thus in the screen I have put 600 hertz. Okay, and on the channel 2 I have given 440 hertz, and I am not changing the frequency of the signal. So let's say, suppose that on the left channel, so one thing is clear that in channel 1 and channel 2 we are having different voltages, and we are plotting we are making a plot in between the voltages for the particular instant of time. So suppose in your channel you are giving a sine wave, okay, sine wave, so let's say it's sine omega t, and here you are giving another voltage that is also sine wave, but this is having some phase shift. It has some phase shift, so this is, let's say, basically omega t minus 90. So if it is like this, that one signal is sine and another signal is sine but 90-degree phase shifted, then you will get the cos omega t. And when you plot sine omega t and the cos omega t with respect to time, then you will see the waveform like this. Okay, so you will see this kind of figure on the screen. Okay, so this is known as the Lissajous figure as well. So just for your just a demonstration kind of thing, I will just make this on the scope. It will take a very less amount of time. Just wait for that. So yeah, see, part. First, actually, I want to show that what is really happening on the screen. Then I will tell you that what is the oscilloscope music. So here, let's go to the signal generator. This is sine wave. We are generating a sine wave. The frequencies are same. Okay. And as I have said that on the channel 1 we will put a sine wave, and on the channel 2 we will put a sine wave with 90-degree phase shift. So we will put the phase shift at this part. So let's put a 90-degree phase shift. Okay, so basically now our speakers will get two sine waves which are shifted by 90 degrees. Okay, so first you see on the oscilloscope, yeah, can you see that here we have two sine waves on channel 1? This is for channel 1, this is for channel 2. Okay, we have two sine waves which have the phase shift of 90 degree. Okay, so these are the two sine waves with 90-degree phase shifting. Now, as I have told you in the drawing, that if you plot these two waveforms, so here on channel 1, this is basically sine omega t, and here on the channel 2, it is sine omega t minus 90 degree. So it is basically a cos omega t. So when your x-axis is sin omega t and your y-axis is cos omega t, then you do get a circle. So that's why we are getting a circle. Now what is the oscilloscope music? We give different signal at the different channels. Means the what should I say? Yes, we adjust the signal in channel 1 and channel 2 in such a manner that instead of getting this circle, we can get some figure in this window. Okay, so earlier we were getting a different figure in the window which was changing with respect to time. Okay, so you can just see that figure if you would like to see. You just give a sweep. Then see that figure will be visible to you. So this is a kind of oscilloscope music that is happening now. So, okay, so using oscilloscope music, you can draw different kind of figures. Okay, so that is the oscilloscope music. Yeah. Yeah, sorry, I forget to share the screen. So just wait for a moment. I will share my screen again. Okay. So I'm sharing my screen now. Yeah. So basically, what I was saying that, sorry that I forgot to turn on the screen sharing. Okay, don't worry. I will start it from very beginning. So basically, what we have discussed that, yeah, here I just told you that if you set your channels, the voltages in your channels in such a manner that your channel 1 is getting sin omega t and your channel 2 is getting sin omega t minus 90. Okay, then you will get a circle. So I'm doing that on my laptop. So just see this. So this is basically channel 1 setting. In channel 1 here we are giving a sine wave. Okay, so sine wave of 440 hertz, and on the channel 2 we are giving a sine wave of 440 hertz, and we have made a phase shift between the two of 90 degrees. So here we have set the phase shift between two channels. So basically, if I will turn this on, so if you turn that on, you will see two signals. So this is one signal and this is another signal. This green one and red. Now you can see that this green one and this red one are phase shifted by 90 degrees. So in our channel 1 and channel 2, we have a sinusoidal waveform with 90-degree phase shift. Now if you will go the XY plot, okay, then in XY plot you can see that in your X channel, in your X axis, in your channel you are giving sin omega t. Channel 2 you are giving sin omega t minus 90 degree, and that's why when you have sin omega t in X axis and cos omega t in Y axis, you do get this kind of circle. Okay. So that is basically the thing what I wanted to show. Now the question was of the oscilloscope music. So I will just give you a demonstration of what oscilloscope music means. Oscilloscope music is actually nothing but it is a sequence of music in which channel 1 and channel 2 are excited in a particular voltage functions so that we can draw a particular figure on the screen. So you can see an example here. So I'm basically what I'm doing, I'm changing the frequency of channel 1 from 440 Hz to 1000 Hz. Okay, now you can see that, yeah, one channel is having the fixed frequency, this thread one is having the fixed frequency, but the frequency of the green one is changing with respect to time. Okay, and now if you go the XY plot, you will see this kind of figure. So let me just slow down this so that you all can see. So I basically slow down the screen. Do you see this? Yeah, you can make it more clear by reducing its frequency. So let's keep this frequency to 700 Hz. Yes. Now see, you can see different type of figures on the screen. And what we are doing nothing. We are just giving two different functions on the channels. Means one is sine wave with a fixed frequency. One is the sine wave with a change in frequency. So this kind of voltage excitations in audio form are known as oscilloscope music. Okay. Yeah. So I think, Parth, that this answers your question, right? Yeah. So if you guys are having any other question related to the things that we have covered today, or related to the things, if you have any query that what we will be discussing tomorrow, if so that you can just read a little bit about tomorrow's topic so that it would be familiar to you. If you are having any question, you can just ask in the chat section. So I would be happy to answer your queries. Okay, so I think we do not have any question. And yeah, thank you for joining this workshop and be safe. Okay, so with this, I think we should wind up today's session. Okay, yeah. So see you guys. We will meet tomorrow at the same time. If you have any query, you can join the Slack channel. We can discuss there. Yeah. Okay. The link of the Slack channel has already sent to you via the map. So please join the Slack channel. So because we have a lot of active discussions on that, so you can take a look on that. Yeah. Thank you. Bye. Good night and be safe.